Thank you, Austin. All right, so yeah, now we have the pickup script attached to this pickup. So if we did things correctly, it disappeared. It's a little hard to tell um, because it's like all white. But if we pause and then use the inspector to check the pickup object, we actually have that this is now disabled. And so now it's invisible. And for rendering the game, we can't see it. So now we have one part of our pickup object completed. And what else did I say about pickups? We kind of want something to, oh yeah, at this point, are there any questions? If you had other game objects, would you have to check if it was the player colliding? Yes, yes, yes. That is a very big part. And I can actually get into that right now. Could I go back to the script? For sure. All right, so this is the script. Oh yeah, and I guess I should go over void start and void update while other people are looking at this on trigger enter. Um, so void start and void update, both of these are functions that are declared within like the mono behavior script. And basically this function, whatever you define in this function, gets called on the very first frame, before the very first frame of the Unity scene. So whenever you click play on the Unity engine, it will run the start command of every single script within your scene. And then for update, it calls it once per frame. So these are two really useful functions that are like that they kind of like leave within the script template because this really integrates scripts within the Unity engine. And so, yeah, Austin mentioned how if we had other game objects, we would have to check if it's the player colliding. And we can actually do that by, if we go here, we have this idea of tags within the Unity inspector. And so we could actually tag, there are several default tags that a Unity scene defines, and one of them is player. And so if we tag our player object as a player, then now within this script, we can tag, one sec, tag. So we could do if other dot tag, yeah, if other dot tag is player, then we can do this. This isn't really necessary for the sake of our simple scene because we don't really have other things that are going to collide with it, but this is in general a good practice. Uh, so yeah, that's the idea of tagging so that objects can work properly. So let's just test it again. And let's see, this should still disappear. Yep. So if we check back, the pickup object is now disabled. All right. Any questions before I move on a little bit? Okay, cool. All right. So next we have, I guess I can go over some other useful functions within scripting. So I already talked about start and update, and something weird about update is how updates only get called per frame. So can anybody think of an issue we have with that? Movement speed? So yeah, similar along that line. Um, the idea of speed is really strange with when we use update. Um, and so like let's say we had something physics related, like if we had to manage an object's like speed within like it accelerates every update. If we had update control that, but we ran it on like a slower computer that could probably run like 20 frames a second, then the object would actually accelerate with respect to that frame rate. And that's something that's kind of strange because then like your entire game will run in slow-mo. And so we want something that, so when we work with physics and stuff, we want to work with something that is independent of frame rate. And that's why we have the void, fixed update. And this is almost the same as update, but it calls with every interval of time that passes. So yeah, this is called every fixed frame rate frame. So like regardless of being 20 FPS or 60 FPS, this will get called the same amount of times per second. And so in general, whenever we have something physics based, we can put it into fixed update instead. And some other useful functions are void awake, awake. And that's just a function that instead of calling on first frame update, it calls on the very first frame that an object is active. And so this is a function that's useful for objects that come in and out of the scene pretty often. So let's say we have debug.log. This is a function that kind of just prints out to the console, I am awake, is what I'll say. And let's see if this works properly. I'll save this and kind of just demo. All right, so if we look at the console, at the very beginning of our scene running, we have this debug.log and it says, I am awake. And so let's try deactivating. Oh, wait. Oh, this only works if it's manual. Whoops. Okay, ignore that demo, but it basically calls every time that the object is set to active from somebody else, from like the function. Okay. And then we also, I talked to you guys about on trigger enter. There's also on collision enter. Private, we'll say on collision enter. And that kind of creates whenever a collider box enters this, enters the objects box. And so these functions are all really similar and do almost similar things. They just work with objects a little bit differently. All right. So now I'll wait on the rotation and movement of a pickup. But like we definitely don't want just one object within our scene or just one pickup object in our scene, right? So what we're gonna do is we explained this a little bit earlier in the other tutorial, but I'll just say it again. We can actually make this pickup object a prefab by just dragging it in. And we can see here that the pickup script is still kind of on this prefab. And so if we were to drag another pickup object into the scene, let's say right here and push it up a bit, it will function pretty much the same way as the other one. And so like that's the idea of prefabs. And so we picked up this one and we should also be able to pick up that one. Cool. So now we have this pickup object. Some questions. Yes, we're gonna be uploading this to the ACM YouTube channel, and we'll also try to upload it to the ACM Studio channel before that. We're still trying to get the login for the main ACM channel, so that might take a little bit, but we'll definitely make these available. Okay.
Christian, can you show your code again?
Yes.
For the,
sure.
I think there's a couple of errors that people are getting.
Is the cube supposed to disappear on trigger enter? For this one, yes. So if it's not disappearing when you have this code, I believe it would be because your player might not be tagged. So if you go to your player object and you tag it as a player, then when we compare other to player, it should equate to true. Does that fix your problem, Peter? I'll just demo real quick. Let's see if we leave the player untagged And then we see how, boom, it doesn't really disappear. That's because we don't have it tagged. But if we tag it as a player, bam, they now disappear. And that function is really useful because, like, let's say we have enemies and pickups on the same level. We don't really want an enemy to be able to pick up something that the player wants. Like in general, like let's say like coins for Mario. You don't really want the Koopas to pick up coins. So that's why we have the idea of tagging to prevent every collision from activating the pickup. And so we're just gonna retag that as player. Uh, and debug. I'm not quite sure what Emily is saying, Jarrett, but if you could get to that, yeah.
I see
Um,
your code.
yeah, for sure. So it's just I am awake, and we can also do debug.log. I am started, and these will call at pretty much the same time.
For some
Uh,
reason, whenever I do the awake one, I can't. It like I have a compiling error. It says debug is an ambiguous reference between Unity Engine debug and system diagnostics debug.
um, I don't quite know that or know what that is. Maybe you could go into
If
the
I delete it
Discord.
though, it like automatically is better.
Yeah. Because debug.log isn't supposed to change anything within your scene. All it
Okay, so can
does
I just
is
delete
print in
it?
the console. Yeah, I just did debug.log to show
Okay.
like the debugging command for most people. All right, so now we have a prefab of the pickup object. And so let's just start littering this scene with a couple of prefabs. And so to do that, we can just pretty much we can just drag them into the scene. I'll just do 4 for now and space them out. And we want all of these to be kind of uniform. So we can click on these and kind of, let's set them all to 1 so that they like uniform. And then from there, we can just move them a little bit further away from each other, just so that the player has to kind of reach a bit to get to them. Okay, and now let's say we want the pickups to be a little bit more interesting. Unity and let's say we want them to like kind of pop a bit. We want them to like other games have like pickups bob up and down, but for our case, we'll just have them rotate just to indicate to the player, hey, this is interesting. Try to run into them. So what we're gonna do is we're going to go ahead and make another script and go back to our script folder, create a C# script, and let's name it rotate. And so again, this should make another .cs file. My unit thing didn't open it for some reason, but yeah. And so this one now is called public class rotate because it's the rotate script. And again, we're gonna extend from mono behavior. Mono behavior is gonna be the default thing you extend from until you get into a little bit more complex stuff. And so let me show you guys again the functionality of public variables. And so public variables, if they're left uninstantiated or like they don't have a value, um, then it throws an error on your system whenever it compiles for like typical C++ programs. But for us, leaving a public vector, public variable undefined isn't necessarily a bad thing. So let's just say public vector 3, rotation vector. This is going to be the vector that we're rotating around. Um, and so now let's attach that to a pickup object. So I'll choose the original pickup object. It's the one over here. I'll just push it a little bit closer.
Wait, sorry. Can you do it again? Can you share your code again? It
For sure.
kept like having me go to like.
Yeah,
No.
it's just right here.
Okay, cool.
So all we're doing is public vector 3 rotation vector. And I'll try to paste that in the chat in case anybody needs it. And so we're going to go back and let's just attach that to the pickup object. So I'm going to go here And another useful way to add a script is just searching up the script name within components, and it'll actually show it, even though it's a custom script. And so now we have this rotation vector, and we can define all three dimensions of it, x, y, and z. And that's because the vector3 data type is just kind of a representation of any 3D point or vector. And so let's say we'll just say, for example, this. I'm going to define mine as 0, 1, 1. You guys can do pretty much whatever you want. It doesn't matter if it doesn't have the magnitude of 1. It'll still work out pretty similarly. And so now we're going to say, hey, so this is the concept of like animating within scripts. This isn't like an animation in terms of like what we draw, but like this is more like animating through physics. And so what we're going to do now is we want these to start rotating on every frame. And how are we going to do that? We're going to use the void update function. And so to do that, we're going to call transform.rotate. And then that's going to rotate with respect to the rotation vector. And so transform basically gets the component of the game object. And so that's going to get, so since rotate is attached to this pickup object, it's going to get this transform right here. And so when we act with this transform and we call rotate, it's going to rotate this kind of, this rotation vector is going to be modified with respect to our defined rotation vector. And so
Okay,
let's
wait.
see if that
Sorry.
works.
The reason I keep not being able to type in the code because it'll keep autofilling for me, and I can't type in the word transform without it changing to crypto API transform. Like how do I literally can't I that's the reason I was having issues with the other, like I literally couldn't type vector3 without it changing to something else.
Yeah, can you go to the tutorial Discord and
Okay,
then
yeah.
try to get that there? Because I'm not quite sure exactly what you're talking about. I've never personally ran into it, but if you screen share for them, it should be good. Okay, so we're gonna try running this. Cross our fingers. And now we have a pickup object that's kind of dynamically moving on every frame. It looks really smooth, but yeah, this is something that gets called every frame. And notice how the other three aren't rotating. That's because if we look at the inspector, they actually don't have the script because we only attached it to this particular object. And so to fix that, we're just gonna go here and we're going to right click on this script and say apply to prefab pickup object. And now it should push to everything else. Yeah. Now here we go. Now we have this, we have the prefab now stores that, hey, we need to rotate this object. So now they all have the rotate script. And so what I just did there with right clicking and adding the component to the prefab is really useful if you ever create a prefab, but then you work with it within the scene, but then you're like, hey, this kind of behavior should be mimicked in every single other object of this prefab. So yeah, that's just the idea of pushing it to the kind of saved prefab asset. And so now we have that they rotate, but they rotate really fast. That's not too much of an issue right now. I can get into that later if we have time. But yeah, are there any questions at this point? And yeah, the idea of getting a game object to transform and manipulating it with an update is going to be pretty common. I'll show some other ways we can change this with transform dot, let's say, we're gonna say, I'll just modify the actual position themselves right now. So let's say local position vector 3. Let's say new vector 3. We'll say 0, 0, 0. And so this isn't actually going to be like super functional for the sake of our level, but I kind of just want to show. Oh wait, no, sorry, equals. Okay, and then so this is going to basically set every pickup's location to 000, and let's see if that works. And so yeah, if we pause now, all the objects disappeared from their initial location, and we modified the position within the script. And obviously this isn't too functional because it's not useful to have everything at the exact same point, but that was just a demo of like a different transform function. And so yeah, that's scripting the pickup objects movement. What other thing can we do with scripting? We'll say pickups obviously should do something for the player. So let's create a score system. How about that? And so to create a score system, we're actually going to go to Canvas. We're going to expand that, and we are going to create a UI element, and we'll just create a text element, and let's call it score. And so this score text element isn't really going to have anything yet, but we will, real quick, we're going to modify it so that it kind of displays in a reasonable location. Let's see. So yeah, the way canvases work are really dumb in Unity because they take up like the entire screen. Wait, shoot. I'm just gonna. So we're just gonna move it. Let's just move it up. Let's see, does that change? No, that didn't change it. Wait, Jared, how do I get this to focus on the score again? I hate working with canvases. Hello, Mr. Jared.
Sorry, can you say that again?
Yeah, I just basically want to be able to move this, but I can't really see it. How should I do that?
If
There we
you
go.
want to
Cool.
just, yeah, doing that's not a good like fix, but if you're just doing it for a simple thing, it's fine for that.
Yeah, it's just something simple. So yeah, we're just gonna push this to the left. We'll just move it right here. And so if we check, the score is now here. Or I'm actually gonna just disable this text for now, just so that it can be a little more clear as to what we're looking at. But yeah, now we have on our game object, or on our game scene, we have a little score text element on the left-hand side. But this isn't too useful because if we pick up an object, we're not really going to get anything out of it. Oh, well, I should disable how the script is pushing them. But yeah, so this isn't going to actually keep track of score yet. So how are we going to do that? We're going to add another script. And so let's just say we have a script and we're going to call it score handler. And we're going to make a new script under the player object this time. And we'll call it score manager, as I said earlier. Boom. And the way I made a component this time wasn't really by right-clicking within the project folder, but rather adding it as a component. So now to edit it, I can just double-click on the script and it'll open up where the script is. And if I click it again, then it'll open it in my code editor. And so now we have a store manager script. And so because we're working with UI specifically, not all not all like kind of aspects of the Unity engine are loaded into like this C# environment, despite it saying using Unity engine. A couple of sub branches of the engine aren't added immediately, so we're going to type using Unity engine.ui. And that's going to allow us to do a little bit more with the UI system. And so now within the public class, we're going to just define a public int called points. And we're going to default it to 0. And we're also going to say a public text element. And it's going to be called score text. And we'll just make this empty for now. Oops, we cannot convert to string. Oh, oops. Okay, yeah, we're just gonna leave this undefined for now. Okay, so what I did here is I mentioned earlier how we could leave public variables blank because we can edit them, but we can also give them a default value. So if we look back at our inspector, we can kind of see how this little points variable defaults to a 0. And we can also default it to a 5 once this updates. And so, yeah, so this one didn't because we didn't reattach it, but let's say we'll add the component again, score manager, it's 5 by default. And so that's just a useful thing to keep in mind. And now we're gonna say, hey, we want a way to increase score. So let's just make a function called, this is actually going to be a function of our own, and it's not related to the Unity engine at all this time. And so we're gonna call it increase score. And so what do we want to do when we increase score? Let's just say points plus plus, and that'll just increment it by 1. And we also want to say, hey, this score text needs to change. I'll get to that in a second, Peter. Score text. And so this score text is a UI text element, and it's not actually a string, but rather a text element that is attached to this. That's like, for example, yeah, so it's a component of a game object. And so text components have a text field that obviously kind of shows what's being displayed. And in order to edit that, we actually have to say dot text. And then we're going to say that is the text we want to display is score plus the new points. Because otherwise, if we didn't do this, the score would be incremented. The score would be incremented behind the scenes, but not visually. And so
I think
now,
you put a minus sign instead of a equal sign.
Where did I put the minus sign?
Next to text, score text dot text.
That's a equal. I think that's an equal sign.
Oh, sorry.
No, all good. All good. Is my screen like rendering properly for you guys? Is it too small, too big? I can try to zoom in if you guys want.
I see
think
the
you
equal
might-
sign.
Sorry, Alex.
I just made my screen smaller so I can like see both. So I think that was probably my
Okay,
bad.
I'll try to zoom in just so that you guys can see a little bit more. Okay. So yeah, Peter just said, what's the function to rotate again? I'll just go back to my rotate script really quick. And so pretty much all of it is defined by having a public rotation vector, and then updating within the updates, we have this little transform.rotate. So yeah, that's pretty much the entirety of the rotate function. Yeah. Yep, for sure. All right, just gonna save that again. And yeah, so now we have this increase score function, but this doesn't actually do anything for us yet because we're not calling this anywhere. So we're gonna have to figure out how to do that soon. So real quick, we're going to go back to Unity. Ateta? Yeah, no problem. See you later, Daniel. I'll catch you around some other time. So now if we go to this player object, we have score text. And this is a public variable that we declared to be of type uText. Well, unityengine.ui.text to be specific. And so we don't have that within our script yet. So the way we're going to do this is, remember this score function, this score text we made earlier? We're gonna say sample, just to show that it changes a lot. And so we have this text element, and this text element has a text component. And so what we do now is we take this player and we have this script and we just drag it in. And so now what we just did is we allowed this script to now find this score text element in some way. Now, this is like usually the easiest way to get scripts to interact with other game objects, because right now, if we look at pickup objects, it only kind of interacts with itself. And so in general, a quick way to having scripts access another game object is to just define a public variable of the type we want. Okay, so now we can see whenever we call the increase score function, the attached text game object will have its text box changed to score, score plus points. And so we still need a way to call this increase score, because it's not attached to, or like it's not coming from mono behavior or something. So it's not like vote start or update where the Unity engine naturally calls it. So the way we're going to do that is, let's go back to our pickup script. And so we obviously have this start and awake, but we want the score to increase at the same time as the pickup disappearing. So what we can do, oh, Peter, I got you. Yeah, that's because earlier I tried to do this, like string, but this text element isn't actually a string. It just has a component that is a string. So if we look here, we're not actually modifying the entirety of score text. We're just modifying the dot text component. Yeah, so adding that dot text allows it to access the string field that we need. Okay, so now we go back to our on trigger enter. And what we can do is, since we know that the player is the one colliding, and we know that the player is going to have this score manager script, what we can do is other dot get component, and what get component does is it basically, we have this game object, or sorry, this is a collider attached to a game object. So when we call dot get component, it gets a component from that game object. And we know other in particular is our player. So what we can do is we get component score manager. And we can see that pop up really easy. And this is a function, so we'll need the parentheses. And so now what it's doing is it's returning this public, it's returning an instance of this public class. And so what we can do now that we have score manager, an instance of score manager, is we can do dot increase score. And so this is one of the ways that like Unity, like the Unity game scene hierarchy and stuff, like kind of like is really special. So if that's complicated at all, just let me know and I can try to re-explain it. But yeah, so now functionally we should have that the score text element should change every time. So let's see. So right now we just have score is sample, but now we have score is 6, and that's because it's 5 plus 1, because I left the default score to be 5, and every time we run into it, we increment our scores. So now we have more stuff that kind of dynamically changes throughout our scene. And so now we have a score of 9, which is kind of like the max we could get since we only had 4 pickups. All right, any questions at this point? So I'll just bring this up again. Yeah. So again, this other is a collider component. This collider component is attached to a game object. And so we can get a component of that game object, and we specify which component we want within these kind of I forgot what these are called, less than and greater than signs, and then that's a function, which is why we have the parentheses. And so again, that's just going to rotate an instance of score manager that's attached to the object that we collided with. And then we can just call increase score. And that's why this is getting called. All right. So yeah, so now we have the idea of a rotating pickup that kind of like affects the player in some sense and disappears. And so let's just do some more changes. And like, let's say, hey, I want pickups to be worth different. Not all pickups are created equally, I guess. And we're gonna make this one, gonna make this material, sorry. Can I change the material here? Oh geez, how do I change material again? Okay, we're not gonna change material for now because I won't do that right now, but let's just go back to our pickup script. And let's say, hey, I want this to be a little bit different. And so we'll say public int value. And let's have it default to 1. And so now each pickup is going to have a value of 1 is what I'm intending. But we can see here how increased score doesn't really take in any values. So what we're going to do is we're going to change this increased score to actually accept an integer value. And I think we can do this defaulting it to 1. So we have int value equals 1. So 1's going to be the default value, and we'll do plus equals value instead. And so right now, since we didn't pass in our unique value, it should still function the same. Let's just test that.
Christian, can you go back to that script once you show the demo?
This one?
The one where you just added the score thing. Yeah, that one.
Yeah. So what I did here was I added an argument that has a default value, and the argument is an integer that equals 1. And so right now, it naturally adds 1. Does anyone else need this right now? That's good. All right, so now we can actually pass in this defined value. So we're gonna have increased score by the value we have within this pickup script.
So there's also a question of can you re-explain the canvas?
Yes. So the canvas, if we look here, the canvas is kind of this really big thing within Unity that represents a screen. And we can see how it's really big because our scene is all the way down there. But yeah, so the canvas is just this entire thing that represents the screen. And this canvas usually hosts a bunch of text, a bunch of UI elements. And so I can make a UI element, and let's make like a button, I guess. And so now we have this button and we can shift it down, I suppose. Let's shift it just like all the way up, I guess. And so now this canvas kind of follows the player because it's kind of attached to the screen and not the player. Even though we didn't attach it to we didn't add any scripts to it, this canvas position, like this canvas is always going to be able to be visible. And that's the idea of a canvas system. And so that's the idea of a canvas. And we also have this score text element. I'm just going to delete this button because it's just for demo. And we have this score text. We have this score game object, and it has a text component. And this text component has a little text value. And so this text value is what we actually see on the screen. And so no pickups collected. You can see when I type that, it shows up on right here because the score's actual position is on the left side of the canvas. It's a little bit hard to tell because this canvas is really big, but yeah. So if we like shift this up or down, it'll reflect in the game scene. So now we can shift it back down, and it's now lower. And so yeah, that's the idea of the score. And we edit this score using our score manager script. Score manager script is under this player object, and we pretty much just clicked this score and dragged it into here, and that allowed this score manager script to edit the score text game object. Sorry, to delve into the specifics a little bit more, this is actually not getting the game object, but just the text component of that game object. Unity is pretty good with like kind of auto translating things, but yeah. So when I drag this game object into this text, this this variable field that's for text, it kind of extracts the text element, the text component from it. And then does collected get cut off if there isn't enough space? Oh yeah, that's right. So right now this isn't like big enough, so we can make the font size smaller, for example, and it should display now. But yeah, that's kind of related to how like each scene has like a box, and you can edit like the size of the box, or have it overflow. That's like, and like UI is like a whole big thing that we could host another tutorial if you guys are interested in. But yeah. Okay. So now, oh, by the way, Peter, did I explain things well enough for you? Like, just let me. Okay, cool. Any other questions you got? Okay, cool. I'll just continue on having each object kind of valued differently. So now if we go to the pickup script after we edit it, we have a value data field, and let's just call this, we'll just say this one's worth 3. This one's worth like 5. We'll say this one's worth 2. And this one is going to be worth 0. These are really arbitrary values that I just chose. And we're going to go to the score manager script, and I'm going to set the points back down to 0 so that when we start the scene, it has a value of 0. And so now let's go ahead and have it. Let's say, so this one's worth 3. This one's worth 2. That one was worth 5, and this one should be worth 0. So yeah, our function worked correctly. So now that's just the idea of having like being able to set a little bit more unique behaviors per object by adding like some public data fields that you could edit. Okay. And now, yeah, that's what I had for most of the tutorial. We got through it a lot faster than I expected, but now we can kind of like play around. And if you guys have like an idea of a power up with, I think Jarrett like mentioned move speed, we can use the rest of our time slot to just go over a little bit more complicated stuff like that. So, but yeah, right now it's just like open to whatever you guys want. We can work on. Or if you guys have any questions, I can try to answer them.
I have a question, but it's not like, I don't think it's really Unity based. So
No,
do you
I'll use.
Some of your objects and functions turn different colors because they're from Unity and it recognizes that it's from Unity. Mine is just white. How do we make it so it recognizes that these are functions and objects from Unity?
Jared, do you know the answer to that? Because honestly, when I installed everything, it just kind of inputted everything properly. I used to have that issue.
Sorry,
with
can
my
you
other
repeat that
computer,
again? I was
but I don't
helping
know.
Emily with something.
Yeah. Alex, do you mind
Oh
repeating
yeah,
it
sure.
again?
Some of the objects and the functions from Unity aren't like recognized by Visual Studios as being from Unity, and so they're all white, and so it doesn't like recommend the autocomplete functions and stuff. Yeah.
Oh, the autocomplete. To be honest, mine doesn't actually have the autocomplete on. They'll still work as long as they're typed right, but I don't remember exactly how to fix that. Do you remember, Christian, how to get to do autocomplete?
Let's do some research.
I can research it later on my own, honestly. I was just wondering if you guys like knew off the top of your head how to fix it.
Can you try going to your Unity editor and then preferences, external tools, and then changing that to be your version of Visual Studios? Otherwise, I'm not quite as sure. We can help you later if you want after the tutorial in the Discord. But yeah.
I'll try to figure it out tonight.
Okay,
And then if I
for
can't
sure.
figure it out, I might like come back and
For
ask.
sure. All right. Okay. Any other questions?
Sorry, I just actually found out that Athena said there's a plugin in the Visual Studio installer for Unity that will allow it to work.
Okay. Do you mind if Athena kind of screenshots how to do that so that she can send them to Alex later?
Athena Christian wants you. Oh shoot, sorry. I need a minute to mute.
All good. Yeah. Okay. So now let's just play around a bit, and let's say we wanted our script to speed up the player. And so the way we're gonna do that, does anyone have any ideas how we're gonna do that? Okay. Get the player's move speed variable and change it. Yeah, that's pretty much how we're gonna do it. And so the way I am thinking of doing this is we have the player, and this player has the player movement script. And this player movement script has a public variable of speed. And so what we can do now is we want to be able to access this player movement script. And so we can do that in a really similar way of accessing the text component for our score manager. And so we'll just go back to our script for pickup. And now we're back in pickup. And let's create a public variable, and we'll say it is a player movement script. So we're gonna say public player movement. We'll call it player move. And we're just gonna leave this undefined for now. And so if we go back to our Unity, we can see if once it updates, we have our pickup script, and now we have a public data field for a player movement component. And obviously the only thing we have that has a player movement component is this player object. And so what we can do is we'll just drag and drop, and it'll extract the player movement script from this player. So now we want to be able to increment this. We want to be able to increment the speed within this player movement script. So again, this is during the collision between a player and a pickup. So we can just say something like, player move dot, and we'll say, let's see, it should be speed, and we could just do plus plus. And so let's see if this works. So now we should be able to increment our speed on every pickup. And so we'll be able to see this player movement script has a speed, and now it's 6 instead of its default 5. And so let's see if it works here. Oh, so now we encountered a bug. Does anybody have an idea of what this is caused by? I'll give you guys like 10 seconds. Something with tags. Close, actually. So it wasn't tags, but it was. So if we look at this pickup object, we have that player move is filled in. But for the rest of these, we actually have that player movement is not filled in. And so now, whenever we try to collide with them, it doesn't have a player movement script to use. This pickup in particular doesn't have a player movement script to use. So it's just gonna say, hey, I can't do that, and it won't run the function. So now, if we just drag and drop this player movement. Oh wait, it's not that one. Is it this one? Let's drag player movement into baseline. Okay, it's not that one. Sorry. So it's these two that I added.
Hey
So
Christian,
now,
can you show the script again?
yes, for
The
sure.
like
I'm just gonna finish my tangent real quick, but we
cool.
see how this pickup object has the script attached to it, but this one doesn't. So what we're gonna do is we're just gonna right click and apply to prefab. Reference to options. Okay, so it turns out we can't do that because it's within this player. But what we can do then is we can just do this, this, and this. This is one downside of using that like kind of idea of a public data field, is that you're gonna have to do that for every object. But now it should work for every object. And then Jarrett, which script do you want me to show? Jarrett?
Can you show the script where you added the pickup was it on the pickup script? Sorry.
Yeah.
One where
So
you the one where you increment to the speed.
yeah. So pickup now has this added line of public player movement, player move. And what that is, it's basically gonna ask us to input a player movement component. And then we use that player movement component and increment the speed of that component.
Okay, cool. Thanks, Christian.
And so we have this. So it's again gonna receive an instance of the player movement class, and that instance in particular is attached to the player. And so another way to do this would be other.gameObject, or sorry, no, other.getComponent. And we're gonna, let's try to access the, what do we call it? Player movement script. So we can also do it like this, dot speed plus plus. And so these lines are actually functionally the same. And so let's see if this works. We'll comment this out. And now we have, let's see if our speed is still increasing. So we click on player. And now the speed is still increasing despite us commenting out that line. And we could do this in particular because we knew that we're colliding with the player. But if we didn't have this little if clause and something else with the trigger enter the pickup, then we'd have a bug. So these two lines are like similar function, but like they have different setup. So just keep that in mind. And yeah, let's see. So now we have like speed up. We have that pickups can be worth different points. You guys got any other ideas that I could show you guys? Yeah, that's pretty much most of what I had. I can go a little bit into the next tutorial, but I kind of want to save that. Yeah. What if you wanted to have the pickup last a certain amount of time? Cool. Okay. Yeah, I can do that. So do you guys have ideas in terms of how to do that? Probably using update and a time counter started at start. Yeah, for sure. Is it like threading with time? I mean, technically yes, but we don't have to get into too much specifics with threading and all, because that's what the Unity engine is for. The Unity engine is our savior in terms of going into complex stuff like that. So if we look at the pickup script, now let's say we have a public float named, we'll call it timer. And then we'll default this to be 10.0f. We'll default it to be 10 seconds. And so we don't really need to use the start command for this, since we can just default it to be this, to be within like the declaration of the class. And so for this kind of thing, do you guys think we should use update or fixed update? For sure, fixed update. Yeah, fixed update is definitely the way here, because again, like if we had it within update and I was lagging, then it would kind of like stay for a longer amount of real-time seconds than a faster computer. So we're gonna do this in fixed update, and what we're gonna do is we're gonna take this timer. We're gonna take timer, and then we'll say that it's plus equals to, or we'll just say timer minus time dot fixed delta time. And so I'll leave this up for you guys to read. But basically time dot fixed delta time is like, it's basically going to return the amount of seconds that has passed ever since the last time you called fixed delta time. So this is what I mean with like, we don't have to delve too much into specifics for like time, because the Unity engine handles a lot of that for us. And so if we do this time.fixed delta time, we'll see within this pickup script, when time passes, we're going to have this timer decrease.
What's the variable of timer? Like, what did you make it?
It's a float variable.
Cool. Did you set it to something?
I defaulted it to 10 seconds, so 10.0f. And so, yeah, now we have a timer. We have a way of keeping time for each individual pickup, but they're not disappearing when it hits 0. I'll show you guys now. They don't hit 0, or they don't disappear. So what do you guys think we should do? Set active false for sure. Set the get active, yeah, similar idea. Yeah. So we're gonna say, hey, like, we need to shut you off as soon as timer is finished. So what we're gonna do is we're actually going to do this in update. And so we can do this in update because it doesn't really matter, or like, we could set it within fixed update, but we're kind of relating this to frames now, because we want this to disappear basically on the same frame as it hits the timer. And so since this is independent of physics and independent of time, we can pretty much just say, hey, we can do if timer less than equal to 0, we're gonna turn this to false. Game object set active is false. And so let's see if this works. Boom, boom, boom. So now, oh no, we have 10 seconds. And let's see, as soon as they disappear, should work. Cool. So you guys can see, now they all disappear. And so now also keep note, this timer variable is now frozen. And it's frozen because I didn't get into this earlier, but with how I mentioned active and inactive, they're invisible to the scene. But more importantly, sometimes is that their update and the fixed update functions don't get called when they are inactive. So it's not even the sense of not being invisible, but more of like a sense of being frozen in time. So yeah, that's the idea. That's like a bit more depth behind the active. So like if you ever wanted like an object to be frozen in time and invisible, you can just set it to be inactive. Cool. Yeah. Something else I could go into. We can get it to jump probably. Let's see if we can figure out how to get an object to jump.
Can you go over
Yeah,
the timer code just again one more time?
Yeah, for sure. So the way we did the timer is we declared a public variable. It doesn't have to be public, but I just set it to be public, and we defaulted it to 10 seconds. And so if we wanted these objects to disappear at different times, we could just say, hey, this one disappears in 5 seconds, this one disappears in 7, and so they should disappear at different time intervals. And the way we decrement timer is we declare, or we add this little statement within the fixed update function, and that's going to be timer equals timer minus time dot fixed delta time. And time dot fixed delta time is this this component within the time interface of Unity, and it returns how much time in seconds has passed ever since the last time you accessed this variable. So it's kind of a unique variable because it changes every time you, or calling or like getting this variable once, and then if I was to get time dot fixed up to time again, these two wouldn't really show these two wouldn't display the same kind of value, because there's probably a lot less time that has passed between these two calls of time dot fixed delta time. So yeah, time dot fixed delta time is really good for whenever you need like to add physics of your own, or like have enemies like move along a path. So we could do that whenever you like manually change the transforms of things. Okay.
Why did you add the removing of the object in update and not fixed update again?
Could you repeat that one more time? Sorry.
You added the like if statement to remove the object in update instead of fixed update.
So yeah, I just did that to show that like it doesn't, or like this if clause in particular can be in either one, but I added it in update because we kind of want this to be set active on the first frame that the timer is less than or equal to 0. So we could add this to fixed update with no issue. I mostly did it as a demonstration that we can have update and fixed update working. Like we can have code in both of these functions so that like anything bugging out. And also to introduce the idea that like if there's something that's not related to time or physics, then we can just add it to update. And I say like this isn't like directly related to time because we're not actually calling anything on timer. We're just checking to see if it's 0 or 0 or less than 0. Is it possible for frames to be skipped? Yeah. So if you look here, let's do a demo. And so because we're calling this time dot fixed delta time at really strange intervals, because that's how like the Unity engine like orders things. And so now if we pause it, we can see that, hey, this pickup script is a value that's really close to 0. This pickup is really close to 0. This one really, really, really close to 0. And then this one's similar. And so, yes, there's definitely a reason to check if time is less than or equal to 0, because Unity isn't really calling fixed delta time at nice intervals, but rather just whenever the CPU kind of gets to it. Yeah. So in general, if you want to check if something is 0, or like check when a thing hits a certain value, you want to check a little bit around that value. Any other questions? Okay. Let me just review my notes real quick. All right, so let's just say we wanted to have a jump for some reason. Like maybe later on in this level, there's like a little ramp that we have to jump up. And so let's figure out how to do that together. So under this player movement script, we have this float horizontal, float vertical values, and we redefine those according to input.getAxis. And so input.getAxis is basically going to return like a value between -1 and 1, depending on if you're like holding A or D or neither of those in terms of getAxis horizontal, or like it's going to return -1 if you hold S or 1 if you hold W when you're getting it in terms of the vertical axis. And so this is the idea of having input related to like relating input with our scripts. And so now we have a force vector that utilizes both of those. And then we add force to using those. And so what if we wanted to have something with jump? What do you guys think? What's a good button to use, and like what's a way we could integrate it with this? Spacebar, give it Y velocity. For sure. Is it Y? I indicated. Yeah, it's Y. So you can tell it's Y because horizontal is basically our left and right because it's A and D. Vertical is our W and S, so it's up and down. And then this is 0 right here because we're not moving in the Y. And we can tell in Unity with this little thing at the top right, you see how it's rotating. Y is kind of our idea of like straight up. And then right now, if we look down, the positive X is this direction towards the right of my screen. And the positive Y is the top direction of my screen. And so, yeah, let's just say we wanted to have a jump. So we're gonna say void update. And so the reason why I'm gonna do this is because we're going to do a function that kind of is like more critical to being on the same time as a frame. And what it's gonna be is if input dot get key down key code dot space then we're gonna say game object dot all right now we're gonna say this dot get component dot get component rigid body we're gonna add force new vector 3 0 we'll say 10 0 cool. So yeah, this is kind of a lot. Let's kind of go over it. The reason I put this in the update function, first of all, is because the way we are getting input for this is different from the way we get input from this. If you notice, like we use input.getAxis, this isn't really reliant as to when we start pushing A or when we start pushing D. it's kind of this idea of keep moving in that direction as long as we are holding D or A or S or W or any of those. So it's not really critical that we get the same, like we get the exact point that we start like pushing down that button. But for spacebar, we kind of care about like the initial moment because that's when we're going to add like a burst of velocity in the y direction. And so that's why we're going to use this in update. Sometimes get key down will work in fixed update, but in general, I've found it to be better to do it within update. So we're gonna have get key down. This is a function that returns a Boolean, true or false, depending on what key code you pass in. And so the key code I'm passing in is keycode.space, which is equivalent to pressing the space bar. So as soon as I press the space bar, the frame that I start pushing the space bar down is this is going to return true. And so we're gonna have get component rigid body. This is the same idea as right down here, except we're just kind of adding in this arbitrary 10. We'll say an arbitrary 1. Okay. So now let's see if this works. Before we run this, do you guys have any ideas on what bug might arise when we do this? Not necessarily a bug, but possibly an unintended feature. Do we need to turn it off? Yeah, similar idea to that. Not exactly the idea of turn it off, but I'll just see if this works. So let's jump. Wait, is that changing the Y? Ooh, wait, no, okay, player. So hold on, this is actually not working as intended. Whoops, my bad. Let's see what's going on wrong. And so this is gonna get into my debugging process a little, but if there's ever something with input that I'm curious about, then I just say leave kind of debug statements is jumping, is what we'll say. And so let's see if we ever can actually get into this if statement. So let's go here and reload this. And let's see if it's printing. So we are getting into the if statement, but we're not really moving in the y direction. And let's see if we can figure out why. So we have get component, rigid body, add force, vector, let's say 10, and then there's no dot impulse. Yeah, this might be part of the reason. Cool. Okay, yeah. So I did 2 things there. And so I was pretty sure that we got into the if statement because of this debug.log showing. And so what I did there is something I forgot about, is that there are different force modes for this add force function. And so I'll just explain the concept of rigid body real quick. And so a rigid body is a component within a lot of objects. In particular, it's a component within this little player game object. And it's basically a component that indicates that, hey, this game object interacts with physics a little bit in terms of like how it like accelerates, decelerates, and like kind of collides and stuff. It has a rigid body. And so
Can you go on your code again?
yes. And so here we're adding force to it. And the force mode that it's defaulted as is, let me search that up. Unity add force. I'll go back to it in a sec, sorry. So this is the code. I'll paste it in chat real quick. And then we have that the default mode is probably acceleration. Yeah, it's acceleration as its default. But since jumps are kind of more instant in most games, what we did is we said it's an impulse instead. And so impulse is basically the idea of kind of, I don't know if you guys have taken physics before, it's like the idea of instantly changing momentum. And so that's why I have it as my mode for jump. So now we can jump, and it's adding, we can see that the y value is changing a lot actually, and that it has velocity in the y. But we can see now that there is a very unintended feature, and you could tell with my client with my console showing that I can jump whenever I want. And so while this might be useful for some games, it's not particularly what I intended. So what do we do? What do you guys think? Oh, Emily says this tutorial a little too fast. My bad. um, do you need me to re-explain something, by the way? Yeah, I kind of got through my material a lot faster than I expected. Maybe I'm just talking too fast, but if you guys are ever confused, just try to let me know. Sorry, I was still learning how to teach. Why am
Could
I
you go
not?
back to
Yeah.
the jump script one more time?
Yes. So Peter says, why am I not going down when I spam jump? You should theoretically go down if your player has a rigid body attached to it. You might be adding like an incredible amount of force where it's not decelerating in a reasonable amount of time. Like if I did 1000 here, I probably wouldn't see it decelerate. But yeah, okay. Austin said, from what I remember, doing other stuff is have a grounded variable, but okay, yeah, a grounded variable is a really good way of doing it. Only let the player jump if its y chord is 0. Close. So for me personally, is there are two ways to do it. The reason why I'm kind of like a little less inclined to do the y chord is 0 is because if we look here, for expandability, we have our y chord is 1 when we're on the ground. But what if we go here and we go to the next level? Then we have our y is negative 6.1. So if we hard code the ground to be set to a certain kind of value, then it's kind of like a little less expandable or scalable. And so what I'm gonna do is, there are two ways that I'm thinking of. One way, the really particular way, would be to determine what the floor is. And so we have several different things here that we can collide with on the level that we can like land on. And so one idea is whenever the colliders enter each other, we can set the grounded variable to 0. So that's kind of the idea of every time like we kind of like tap the ground, then our grounded variable returns to normal. Or we could just have it a functionally almost similar way is determining when the y vector, the y velocity vector chord is 0. That might have been what you meant, Daniel. I wasn't really sure. Maybe I misread. But yeah, it's functionally almost the same. There's a small discrepancy because if we're going up, then we're obviously going to go down. So there's like probably a frame where our y velocity might be almost 0 or even equal to 0. And so like that might allow you to double jump within the air. But for our purposes, we'll just say that's okay for now. So we'll say at, so end is ground, can jump, we'll say. And so we have the can jump. We're gonna say it's a private variable this time because we don't want anything else to modify our can jump besides our besides our script, our player movement script, and we'll say it's false. It's false by default. So how are we going to modify this can jump? Any ideas? In terms of like where we should set it to true, or how we check to get it to false again? Yeah, for sure. Yeah, both Austin and Alex have some really good ideas. After we jump, make it false. So we can just do right here, add force. After we add force, we say can jump equals false. Cool. And then we'll say, let's see where we can make it, true again. So we could say on collision. Oh wait, let's see. A good function that I forgot about is void on collision stay. And here is a function where it's called once per frame for every collider slash rigid body that is touching another rigid body slash collider. So this is the way we can check if we're colliding with pretty much anything. And so what we can do is we can say can jump equals true. So this might introduce a couple bugs, but for now it'll be functionally what we want. Oh, that might not have updated. Let's see, can jump equals true, can jump equals false, and can jump. I might have missed something. Let me double check my notes. Okay, for now, I'm going to set this Boolean function to public just so that I can see it in the inspector. But let's see. So now we have the player, we have this movement script, and right now it's true. And we can see here, it's not getting set to false until you jump twice for some reason. That's strange. So we know that we're going in here. Let's say, okay. Let's try changing it to on collision enter. Cool. Okay. So now we have our thing functioning pretty much as we want for how we want to do it. Now we can jump over walls and jump off of walls. There's a small bug because we can jump after colliding with a wall in terms of like not actually being on the ground, but it's functionally what we want. And so, yeah, I'm gonna talk about collision stay and enter. The reason why we had that bug earlier was because on collision stay is a slightly different function from on collision enter. On collision stay. We'll just bring this up. So if we read the Unity documentation, it says on collision stay is called once per frame for every collider slash rigid body that is touching another rigid body that is touching my rigid body or collider. And then on collision enter is called once this collider slash rigid body has begun touching another rigid body collider. And so the reason why it worked with enter and not stay is because sometimes we can't really predict the order of which functions are called within Unity. And so this this was getting called and then this was getting called on the same frame because we're jumping off of the floor. So if we add force and set can jump to false, but then we also call the on collision stay because we're jumping off of the ground, that means since we had can jump equals true within this function earlier, that means can jump gets set to true as soon as we jump. So that's like a bug because some things were kind of out of our control in terms of like the order in which Unity processes things. So because we wanted to be able to jump whenever we get back to the ground, on collisions, enter was a better decision for us because then it just props once every time we land. So again, and now it calls. So that's kind of our idea there. Anything else? Yeah, so that's how to jump. And something really useful whenever you're lost in terms of figuring something out is Unity documentation. Unity documentation shows a lot. I can pretty much search whatever on trigger. And it's a good way of just figuring out what each function does in terms of whatever's under Unity. Our speed doesn't affect our jump right now, right? Yes, it doesn't affect. So by speed, I believe you mean like the little public variable we defined. And yeah, this speed, we can see that it's only ever referenced right here within our fixed update. If we wanted it to be modified by speed, then we could do something like times jump speed. We'll call it height. And we can just leave this as 1. And we'll just set a public float jump height. And we'll set it to like 10 by default. And so now we can kind of edit on the fly how much we want something to jump. So now if we set it to 0, we can't jump at all, even though I'm clicking spacebar. If you set it to 100, then, oh, we have to do this. Then we can obviously jump very, very high up. And so, yeah. Any other questions? I think that's pretty much all that I'll cover for now. I don't want to get too in depth, but yeah, that's probably a good start for you guys on scripting and figuring out like the physics engine and all. Again, I can't stress this enough, but Google and Unity documentation are enormous friends in terms of scripting because there's a lot of really particular and like things that we can't like teach all up front, but like a lot of it is just learning on the go how to script and stuff like that. And we do that with the power of Google and Unity, honestly. Yeah. Any thoughts, questions, comments, concerns? Pog tutorial. Thank you, Peter. Peter the homie, always coming out to tutorials. All right, but if you guys don't have too much, then feel free to go. Yeah, sorry that this didn't truly last 2 hours, but yeah, good on you guys for being able to get through the material faster than I expected. For sure, Alex.
Thank you.
Yep. See you, Austin.
I see your notifications released, by the way. I like that.
Yeah, I think I got invited to a normals game or something. Ignore that.
Thank you.
Yeah, see you later. Right. Yeah.
See you guys.
Yep. See you, Peter.
See you, Peter. Oh, he's gone.
Okay, man. I didn't record the beginning of the tutorial, Jarrett. What should I do?
Yeah, I forgot about that too. You may have to re-record the beginning or something sometime. I don't know.
Yeah.
I considered that, but I thought you guys recorded because I came in like 2 minutes late.
Oh, no. Okay.
I forgot.
They forgot to record the very beginning, like the
Okay,
first like 10 minutes or
I
something.
can go over the beginning in this meeting still. So I'll do the thing, and then I'll try to like cut it to the front using YouTube.
Okay,
See if
cool.
that's possible. Okay. So All right. Hello. Welcome to
Hello.
our Unity tutorial.
Oh, he's recording.
Yeah, so you might have noticed how the video is set up. I'm not sure how I'm going to do it yet, but I forgot to record the very beginning of the tutorial. So we're just going to go over what we did right now. And so to begin with, we're just gonna create a new scene, and we're gonna import the assets that Chair has given us within beginner tutorial 2. And so we just gonna import all of those. And yeah, so I'll just briefly talk about this tutorial. This tutorial is kind of an introduction to beginner scripting within C# and Unity. And so what we're gonna do here is let's jump into our prototype scene. And after everything loads, and we want to start figuring out, hey, how are we going to do scripts and all? And so we can see here that a couple objects in this level have scripts. One example is the player object, has the player movement script, and this is actually a .cs file that is code for C#. And we can open that by double clicking there or here, depending on what you like. And it kind of shows this little interface. And this interface is essentially going to be whatever code editor you have. Mine was Visual Studio. And we can see how this is a public class that extends from mono behavior. And mono behavior is kind of this thing that every Unity script derives from, as you can see from documentation. And the name of our public class is actually the same thing as the name of our script. And so whenever we actually attach this script to an object, we're actually creating an instance of this class. And we have like some basic premises of code here, but something interesting of Unity that I'd like to show is there's a public float speed, and this is actually undefined. And this would bring up a pretty big error for other C++ functions, but since we are working with Unity specifically, we can see here in our Unity inspector that speed is actually a variable that we can change real time with the Unity inspector. And so this idea of public variables being like able to be changed kind of however you want is really useful for whenever you want to like be in playtesting and just change things on the fly. And so like we can move faster now. And so having things undefined within Unity isn't necessarily a bad thing. And so, yeah. We also have a function called fixed update. And this is actually a function that comes from that is declared within mono behavior. And fixed update, I'll go into it a little bit more in depth later, but it's essentially a function that gets called every time or every fixed interval of time based on the Unity engine. And so mono behavior and functions like void fixed update and like void start, void update, void awake are all functions that kind of help you integrate your script within the Unity engine. Um, and so I'll get into some of this later, but I think that should be enough of what I didn't cover at the beginning because I apologize, I forgot to start recording at the very beginning. So yeah. Um, and to start off our tutorial, we're actually going to add some stuff to our level. We're going to add a pickup object. And to do this, we're just going to right click, create, cube. Let's name this pickup object. And we want this pickup object to kind of, oops, let's move it up here. We want this pickup object to kind of disappear whenever we run into it. And so what we're going to do is we're going to create a script, and this script will be attached to the pickup object. We're going to call it Let's see. We'll call it pickup. And so to do pickup is we are going to, let's open this up. We are going to basically define a function called void onTrigger enter. And we're going to say game object dot set active is false. And so what this is going to do is when we attach it to our pickup object is whenever we collide with it, we are going to set this to false. So we're going to set the activeness of this pickup object to false. And so let's test if that works out. Bada bing, bada. Oh, it does not work out because it is not a trigger yet. So because I defined this to be trigger enter, and this is not a trigger yet, this is actually going to be a little bit weird. So we're going to do this, and now trigger enter works. So we're just going to restart this and make sure to click is trigger. And yeah, so that should be all I need to cover what you guys missed for the beginning. So yeah, awesome. And I'm going to now stop the recording.